Hello guys, Mr. Bean here, and today we're going to work on a review for conic sections. What I've done is shown you what you're going to see on the test, at least if you're taking one of the Algebros tests, is we will give you these equations on your test. It's not on your review, but I just wanted to give you a heads up that all of these things are going to be on your test. So notice there's not the distance formula, so you need to make sure you know that one, and there's not the midpoint formula where you have the average of your two coordinate points, you divide by 2, divide by 2. So those are things that are not on the test itself. You need to make sure you know those, but all of the rest of these are on the test, but you do have to know what is what. Like for instance, the subtraction one is the hyperbola, the addition is the ellipse, and so forth, and just know how these work, whether it's horizontal or vertical. So you may need to go back in your different individual lessons in order to get that. So let's start off here with number 1. So I'm going to actually go through your exact review, and you can kind of follow along. If some of these problems have changed in future years, well, at least you can kind of follow along with what I'm doing to get an idea of how to do this. So first we're going to do the distance, and the distance formula here is going to be the square root of, and then I take the difference and square it of either the x's or the y's. It doesn't matter which. So I'll just take the x's first. -6 minus a -3 means we'll add the 3. And then I will add, because this is basically, it's just like the Pythagorean theorem. And now let's do the y value. So I have a -3 minus 3, and then you get d equals square root of, so this -6 plus 3 is -3 squared. That's a 9. And here this -3 minus 3 is -6. But when I square it, I get a positive 36. So we have that the distance between these 2 points is the square root of 45. And then you could plug that in a calculator and get it to 3 decimal places. I don't have a calculator right in front of me, so I'm going to stop there. That's just simple plug in a calculator. All right, now the midpoint. If you remember, the midpoint is, I'll come down here, the midpoint is the average of the 2 points. Oh, I don't need to do it down here. I'll just do it right up here. So I'll do a capital M to demonstrate what I'm doing here. I'll take -5 and add the other x value, which is 3, and divide that by 2. And then I'll go to the other one. The y value is 1, and I will add the -8 and divide that by 2, because I'm taking the average. So that leaves me with, at the midpoint, -5 plus 3 is -2. Divide by 2, we get -1, comma. 1 minus 8 is -7, so we get -7 halves. Okay, there's your midpoint. Number 3, we're looking for the perpendicular bisector between these 2 points. So I have 1, 5 and -5, 3. So this is the line that is being connected, but what I'm looking for is the perpendicular bisector, this line here, and it's at a 90-degree angle. So the first thing let's do is find that midpoint right here. Let's get that midpoint. So we will take the average of these 2 points. So 1 plus a -5 means 1 minus 5 over 2, comma, and then a 5 plus 3 over 2. So that's going to give me a midpoint of -4 over 2 is -2, and 8 over 2 is 4. So there's my midpoint that I'm going to use. That's this red dot down here. Okay, now what's next? We need to get the slope between these 2 points. So if we take the rise and the run, then we'll take the negative reciprocal in order to get the perpendicular slope. So let's see what our little m slope is. Change in y's. So we can go 3 minus 5 or 5 minus 3. Doesn't matter which order we do it in. So how about 5 minus 3? Over, now if I started with this 5, I got to start with that x on bottom. So 1 minus a negative means plus 5. So our slope is 5 minus 3 is 2. 1 plus 5 is 6. So that equals 2 6s 1/3. And then that is going to change because we're going to use the perpendicular bisector. So 1/3 will give us a -3 that we're going to use for our slope. Okay, I'm going to circle that thing just as a reminder. That's our slope. All right, so what do we do with this? I'm going to use point slope form, which means we're going to go through this coordinate point, and remember that coordinate point was -2, 4. We found that because it was the midpoint. So y minus 4 equals the slope that we're using, which is -3, because we're negative reciprocal of this 1/3. And then we times this by x minus -2, so x plus 2. So we're using this point. Now that actually could be done, but if we wanted to solve from there, you could go y minus 4 equals -3x minus 6, add 4 to both sides, and you get y equals negative 3x minus 2. So if you were solving for y, that would be your answer for this problem number 3. All right, number 4, we're graphing a parabola. We've got a quantity squared here and nothing over here on the right. So what's the coordinate of the vertex? We have the x value here is a 4, and the y value is a negative 1. So let's go over here. 1, 2, 3, 4, and, oh wait, positive 4. 1, 2, 3, 4, and down 1. There's our vertex. And which direction does it open? Well, the y is being squared, so it's either a left or right. And since the coefficient here is negative, it's opening left. Okay, that's important for where we're going to put our focus. That also means that the axis of symmetry, it's going to split right down. See, we're going to open something like this. We're going to open that direction. I won't graph that yet, but that means right down here on the line y equals negative 1. That's the axis of symmetry. So let's do the coordinate of the focus. In order to do that, we need to figure out what the p value is. So 4p equals negative 8. Therefore, p equals negative 2. So let's use red. From the vertex, I'm moving left 2 spots. There's the focus. So the focus is 2, negative 1. And then the directrix is 2 this way, 1, 2, and then you'll have a dashed line that you could put there. And so that is an equation. The directrix is x equals 6. All right, now, how do we sketch the rest of this thing? At the focus, you have the focal width. The focal width is 4p, so it's 8 across. So if I'm here at the focus, I could go 1, 2, 3, 4, and put a dot, and 1, 2, 3, 4, and put a dot. And there is the focal width. It's 8 across. And let's see if I can curve this thing and not close. And oh man, okay, something like that. There you go. Good enough. We're just kind of doing a sketch here with those coordinate points. All right, number 5, let's get an equation. Now, I would recommend, I know there's not a lot of room on your review there, but I would recommend visualizing this. So if we have a focus at negative 2, 3, there's our focus, and we have a directrix at x equals 2, we have something like this. Okay, this is sideways, I know. There's our directrix. That means that our parabola is going to have something right in the middle that goes like this. Okay, so we need to figure out the vertex. So what is the vertex? The vertex of this thing is going to be right in the middle of these two things. So here you have an x value of 2, here you have an x value of negative 2, so the vertex is at 0, 3. It's right in the middle of these two things. Now that we've got a vertex, what else do we need? We need to know what p is. So the p is how far you are from the vertex to a focus, which is 2, or from the vertex to the directrix. So that is 2. But let's be more specific than just saying a 2, because we know it opens left. So let's make this a negative 2 instead of just a 2. So that way, when we get 4p, we know that this times 4 is negative 8. Okay, now we can write our equation. We know it's a quantity squared equals negative 8 something. So where's the x's and y's go? Let's see. It's going to be a y squared. So we put the y there because it's opening left. And then the y value here is a 3, so we say minus 3. And then over here you'll have x, and then technically it's minus 0, but you don't really need to say minus 0. So I'm just going to put x. And there it's done. Okay, number 6, let me give you another visual of what's happening here. We have a circle, a point on a circle whose center is the origin. So here we've got some circle. 2, negative 3 is some point down there. What we're looking for is an equation of the line that is tangent to this thing. And so you have some line that's kind of coming through the point like this. We're going to get the equation of this line. So what we need is the slope. The way you get the slope is you look from the center to that point, because the perpendicular is going to be tangent to that, meaning it's going to just kiss this circle in one little spot. So let's get the slope of that. That slope is down, let's see, it's right 2 down 3. So it's down 3 over 2. That's the slope of this thing. So the slope we want to use for the equation of the line is going to be the negative reciprocal 2/3. That's what we're looking for, the slope of this line. And then we're going to go through the point 2, negative 3. So y plus 3 equals a slope of 2/3 times x minus 2. And then that could be it. And then let's solve for y on this. Let's see, we get y plus 3 equals 2/3 x minus 4/3. And then when you subtract, we're going to subtract 3, but instead of 3, let's just change it to 9/3. It'll make it a little easier if we see this as the fractions. And I know we don't have a lot of room on this. Sorry about that. And then we get y equals 2/3 x minus 13/3. There's our answer to that one, number 6. And I know you're trying to squeeze this in. You got to write small. Numero 7. Here we go. All we have to do is set up an equation. So it's pretty basic. We have these quantity squared things. It's going to equal the radius squared, which is 64. And then you have your x, your y. The center is minus 8, so you just say plus 8. Here the y value is at -2, or positive 2, so you say y minus 2. And that's it. Real simple there. Just basic equation of a circle. Number 8, now let's sketch the graph of this thing. What in the world is going on? Well, I'm going to first divide this whole thing by 36 because we need it to equal the number 1. And then you can see here, these things are going to start reducing. That reduces 36, 9 and 36, that reduces to 4. This reduces to a 9 on bottom, and that cancels and just becomes the number 1 on the right side. All right, so that lets you know if we have, let's see, the a value is, a squared is 9, so a will equal 3. B will equal 2 because I'm taking the square root of these things. And for this, it's an ellipse because it's an addition. And A is the larger one, if you remember. A is larger than B when it's an ellipse. And you know it's an ellipse because it's addition. So anything else we need, we're going to have the foci down here. So we probably should get the C value as well because that's going to help us. So if you remember, C squared equals, in this case, it's A squared minus B squared. So C squared equals A squared minus B squared. Now just remember for an ellipse, it's the opposite of the symbol. Same with hyperbolas. This relationship is the opposite. So A squared is 9 minus B squared is 4. 9 minus 4 is 5. So C is going to equal the square root of 5. We don't have to get what the decimal is. That's good enough. All right, let's start graphing this thing. -3, 2 is the center. So 1, 2, 3, 1, 2. There is our center point. And the A value is 3. Oh, by the way, does this open up or down? I mean, is this a horizontal or vertical? Since the A is underneath the Y values go up and down, so it is an ellipse that's like this. It's up and down vertical. So the A value, 1, 2, 3, goes up here. 1, 2, 3. Oops, 1, 2, 3. Yep, that's right. Down here. And then the B value is 2, so we'll go right 2 and left 2. Okay, so that's helping us out here. Our center is -3 and 2. Our vertices were A away from the middle, so we're going to go from this point up 3 and from this point down 3. So let's do the down 3 first. -3, comma, -1. And then the other one was -3, comma, add 3, you get 5. My pin's being sloppy, sorry about that. And then the co-vertices are the B values left and right. So we're going to be at a -3 and then go 2 more to the left. So -5, comma, and the Y value stays the same, so that's a 2. And the other one is, we were at -3, let's go 2 to the right. Now we're at -1, comma, 2. And then the foci are going to be somewhere in here. We're going to go add square root of 5. So a little bit more than 2. A little bit more than 2. There's our foci, which we don't really have to sketch on there, but it's just for a visual. So what's changing? The Y values from the center. So the -3, nothing changes. But the Y value 2, we're going to add and subtract the value of C, which in this case is 5. So that's where that comes from. And then you just try to, as best as possible, curve your lines, which I am horrible at, but let's see how good that can be, and then we connect them. Okay, not too bad. All right, there's your ellipse. Okay, an equation for a circle. We got a center here and a point. What I want you to think about down here is that the equation of this circle would be x plus 3 quantity squared plus y plus 15 quantity squared equals, and then we have some radius squared. Radius squared. So what you could do is, there's a couple ways of doing this, and you could take this x and this y value and just plug it in there, and solve for r. Or you could also get the distance between these two things, and if you get the distance between those, that's actually the radius. In fact, let's do it that way. On the solution guide, I think I did a little differently, so let's just get the distance. Okay, the distance between these points will give us radius, so I go -3 minus a -6, square it, plus, and now I'll take the y value, -15 minus a -16, and square it. And then what I get is the square root of, let's see, -3 plus 6 is 3, 3 squared is 9, plus -15 plus 16 is 1, 1 squared is 1. So the distance is the square root of 10, that's the radius. So the radius squared is just 10. So my formula is x plus 3, quantity squared, plus y plus 15. See, that represents our center point, -3, -15, and then it equals the radius squared, which in this case is 10. Okay, number 10, we are going to do an ellipse. Let's figure out what this thing looks like real quick, because that'll help us with our equation. The vertices are at 9, 4, somewhere over here, and -1, 4. So if those are vertices, that means the ellipse is a vertical ellipse, like that. I mean, not vertical, excuse me, horizontal. And the big idea with that is that, whoops, I can start setting up my equation now, because I'm going to have a quantity squared, it's addition because it's an ellipse, another quantity squared, I'm getting sloppy, and that equals 1. And if it's left and right, well, I can just put the x here and the y there, but I know that it's stretched left and right, so this is where my a squared goes, right here, and this one's where my b squared goes. Now I'm not going to write the a squared, b squared yet, because I'm going to figure out the numbers. So where is the center first? Let's get that. The center of this thing is right between the vertices, the midpoint of this stuff. So the midpoint, 9 and -1. Add those together, divide by 2. 9 plus -1 is 8. Divide by 2, you get 4. And then the y values, if 4 and 4 average of those, it's still just 4. So that's pretty easy. Now what else do we need? We need to get a. A is going to equal the center to a vertex. Well, look at that, 4, 4 to 9, 4. The y values are the same, so it's really just the distance between the x's, which is 5. And then what is b going to equal? We do not know, but I have here the value of c. And c is from 4 to 7. That's a value of 3. So what in the world is b going to equal? Well, we have the relationship of c squared equals a squared minus b squared. So if we plug in what we know, in this case it would be 9 equals 5 squared, which is 25, minus b squared. So you have that. Now if you solve this, you're going to get -16 equals -b squared, and then so forth. You solve for b, you'll end up with b is equal to 4. So the a we said goes underneath the x, the a squared I should say, so we'll put a 25 there and a 16 there, and then we put the center x minus 4 and y minus 4. Number 11, let's draw another quick little picture. Let's see, vertices are 1, 5. There's a vertex, -19, 5, way over here somewhere, and the vertices tell us that it's opening left and right, and that's a big deal because that means, remember in hyperbolas, it's subtraction. It's going to equal 1, and in this case, quantity squared, this case the a squared always goes first in hyperbolas, and so we got to figure out the a and the b and square them, put them on bottom. Whoops, that's squared and squared. But it also means that since we're moving left and right, that the x value is going to come first and the y value comes second. So let's get the center of this hyperbola, and that is the midpoint. So have 1, add a -19, that's a -18, divide by 2, you get -9, comma, and then the average of 5 and 5 is just 5. So, all right, x, so that means we go x plus 9 and y minus 5. How about a? A is equal to the distance from the center to a vertex. The y values are the same, so how about negative 9 to 1? You could think of that distance, or you could think of the distance negative 9 to negative 19. That is a distance of 10. So a goes first, so this is 100, because it's a squared. And then the value of b is equal to the center to the ends of the conjugate axis. What is this here? And remember, it's vertices, it's the transverse axis. The conjugate axis is not to the vertices. So we're going negative 9 to negative 9 is nothing. So how about from 5 to 11? That's a distance of 6. So we put 36 down there. There's your answer for number 11. Number 12, now we get a graph, and we're just going to write the equation based on the graph. So let's label a few things here. Here's that center point. The center point is going to be, what is that? 2, 2. All right, and then it's moving left and right. So here, let's just start setting up our equation. I have a quantity squared minus, because it's a hyperbola, and then another quantity squared. It's going to equal the number 1. And let's see, I'm going to open left and right, so that means the x comes first, the y comes second, because it's horizontal, left and right, and the a squared always goes first. Okay, so that means, what is a? A is the distance from the center point to a vertex. That distance from here to here is 2. So we square it and get 4. Oh wait, we can do this too, the 2 and the 2. So x minus 2, y minus 2. And then what goes over here, the b squared? The b squared, how do we figure that out? Let's use a, do I have a triangle? Yeah, there we go. Let's look at this pretty triangle there. So the a was a 2, the b value going up and down, that's just a 1. So we put a 1 squared goes there, and that's it. So really you can just say y minus 2 quantity squared here. You don't even have to say over 1. But that is the answer for that one. Number 13, rewrite into conic section standard form. So let's reorder this thing. We have the x squareds, and with the x's, there's no other x's, so we're good there. Minus 25. You know what, let's take out the y squared. So if I take out a minus 25, now I have y squared, not take out y squared, leave y squared, so that there's a coefficient of 1. And then we just took out a negative 25, which leaves this as a plus 2y. Now I'm going to leave myself a little bit of space because I'm going to complete the square here. This is where we complete squares to get in standard form. And I brought this minus 250 over, so now it's going to equal a positive 250. So what do we do next? We will complete this square. Half of 2 is 1. Square that, and you get a positive 1. So if I add 1 on the left, you'd think, oh, I got to add 1 on the right, but it's actually not a 1. It was a 1 times negative 25. So to balance this, I have to subtract 25 over on the right side. Now it's balanced. So I have 9x squared minus 25. Now this is a perfect square, so we can call this a quantity squared. And what's inside here? Y plus half of b. Half of b is a 1. And then this is going to be 250 minus 25. That's 225. All right, our next step is to make sure that this thing equals 1. So I need to divide every term by 2. Oops, that's supposed to be a 5. By 225. Divide by 225. And if you need to, you can get your little calculators out and check these. That reduces to 1. This reduces to 25. That reduces to 1. This reduces to 9. That cancels and becomes the number 1. So final answer, x squared over 25 minus, here I have y plus 1 quantity squared over 9 equals a 1. All right, a couple application problems here, and then we are done. Let's draw a little parabola heating oven, solar oven thing. That basically means this, it's going to come down and bounce to a focus. That's what the sun's rays are going to do. And so we need the heating area. Where's the heating area here? Let's put a focus somewhere around here. And it tells us that this distance here, the p-value, is 2.5. So that distance up here to the focus is 2.5. Now, the most common mistake students make when we're doing these things is they think that the focus is right here where the parabola stops, and that's not the case. It might be outside the parabola or further inside the parabola compared to where the edge of our parabola stops. So just be careful about that when you're doing these on any tests. Try to not think of it as where it's 4 feet across. Here, in fact, I'll change my colors here. So this distance here, when I'm looking about how far across is it, it's 4 feet across. That is not the focal width. This is not where the focus is right there. The focus is somewhere else. But if it's 4 feet across, that means it's 2 on one side and 2 on another side. And the reason that's so important is because we can say that this is a coordinate point. If the vertex is at 0, 0, which is the easiest way to think of this, if that's at 0, 0, then this coordinate point right here is at, what's this distance? From here to here, that's a distance of 2. So the x value is 2, and the y value is something that we don't know. That is our how deep the oven is. So here's how this works. You take the equation, let's see, it's x is being squared. So we go x squared equals 4p, so it's 4 times the p value is 2.5, because it said, because it said that it was 2.5, the focus is 2.5 from the vertex, so it's 4 times 2.5, and then times that by the value of y. So if we plug in this x value of 2 and square it, 4 times 2.5, that's 10, 10y. You divide both sides by 4 or by 10, and that is how deep this solar oven is. Okay, I'll stop there. You can just do that quick little math. And then the very last one, cross-section of a rope pulley. Okay, this gets a little confusing. This picture also is misleading because it's got this shaded area here, and it makes you think that this is A and this is B, but that's not quite right. A is definitely, I'll go back here and put that blue in. A is definitely a 4. But the B value we don't know. This shaded region, it really does throw that off. It's supposed to show the shape of a pulley is what this is actually doing. So here's how this works. It says the transverse axis is 8 centimeters long. So that definitely means that A is half of that. So A is 4. B, we do not know, so I'll put a question mark here. But we do know that C is, it says here that the foci are 2 square root of 6 centimeters from the center. So C equals 2 square root of 6. So if you remember, the Pythagorean relationship here is C squared equals A squared plus B squared. Why is it addition this time? Because the hyperbolas, when we're doing hyperbolas, that's a minus equation. Minus with a fraction equals 1. In fact, I'll just go ahead and set this up. So if it was minus in the equation, then the Pythagorean relationship is the opposite of that. That's how I like to remember these things. So quantity squared, it's opening left and right, so that means my x will come first, my y will come second, and I've already got the a is always first, so I know this has to be 16, a squared. Where's the center? The center is at 0, 0, so you could just say minus 0, so we don't really even need that part of it. And the last thing here, we need this b, and then we're done. So how can we do that? You set up this 2 square root of 6 squared. So 2 square root of 6 times 2 square root of 6 equals, so that's my c squared, equals a squared plus b squared. So 16 plus b squared. I am really trying to squeeze this in here. I'll draw a red line here to separate this. And then 2 times 2 is 4. Square root of 6 times square root of 6 is 6 equals, then I still have my 16 plus b squared. This is 24. 24 minus 16 is 8. So 8 is b squared. Now be careful here. 8 is b squared. It's not that b is 8. It's b squared is 8. So that's what b squared is right there. You just put an 8. And there you're done. All right, that's it for this review. I really hope you do well on this final test here for Unit 11. Hope for those of you who are going on to Unit 12, hopefully there's a lot of you going on to Unit 12, going to have some fun matrices there. And so if that's the case, I will see you back in the next unit. Good luck on that test.